So right now we want to talk about the third business unit at PADT, rapid prototyping. What rapid prototyping is taking a 3D computer model, converting it into a real plastic part. And the different technologies all kind of work the same. You take a 3D part, you slice it on the computer into thin layers, and then you use some sort of a machine to build a part up one layer at a time. In-house, PADT has 4 different technologies that we can use for our customers. The first and the best known is stereolithography, also known as SLA. SLA parts are really high quality, they have a nice surface finish, and the materials can be clear, they can be solid. You get a really nice variety and high quality out of stereolithography. It's also the most expensive process, and the chemicals we use to make the parts can be toxic. So it has its advantages and disadvantages. Next to those, we have examples of selective laser sintering. This is a process where you take a powder and use a laser to make the powder bind together. This stuff is really strong, and what we'd like to do with this technology is make big, strong parts. Another advantage of the technology, if you can see this in the video, is that we can build parts assembled and working, like this gear train we actually built as a single part, and we just blow the powder out when the part's done being manufactured. The third technology is fused deposition modeling, and it's like a computer-controlled cake decorator. We squirt out a plastic through a nozzle onto a elevator and build the parts that way. What's great about this technology is it's very affordable, it can be run in an office environment, and the parts that it makes are very strong. This is actually the most common technology in the industry right now, with the most machines and the most parts made in a given year. And lastly, we have our newest technology called PolyJet. And what's neat about it is that it uses a material that can be either very soft or very hard, and by mixing the two materials together on the machine, you can come up with whatever stiffness you want your part to be. So we've been using this to make parts that are, say, overmolded, like this piece of plastic that's got rubber around it. And here's an example of a rubber wiper on a part. So we can really give the customer what they want with this. It's also very precise. The first technology that we're going to look at in the area of rapid prototyping is called fused deposition modeling. And these machines are from a company called Stratasys Inc. And PADT is very proud to be the distributor for these devices in the Four Corners region as well. The way these guys work is they take plastic and heat them up in a nozzle and squirt out the plastic like a glue gun. Or think of it as a numerically controlled cake decorating machine. So one layer at a time, it squirts out a very thin thread of material to build the parts. These parts are inexpensive and very strong. And it's, as you can see, it's sitting in our offices. You can run these pretty much anywhere, literally on an engineer's desktop. This is PADT's seminar room. If you ever are lucky enough to come to PADT for a big meeting, we'll hold it in here. We can reconfigure it to fit up to 50 people, or we can have small informal meetings as well. This facility was originally owned by Motorola and used by them by one of their engineering teams. And they did a really nice job setting it up. So we were very lucky to inherit this facility from them, and this really nice seminar room is one of the nicer things they left us. Okay. Another nice thing that Motorola left us were these great cubicles. This is where the bulk of what PADT does goes on. It's easy to remember the prototyping and the labs, but the majority of PADT's engineers spend their lives in their cubicle working on cool things. Clinton here is doing CFD engineering, which is modeling fluid flow using simulation, and he spends all day building these models, running these models, and evaluating the results for customers. He also provides support to our customers that use this software at their own companies. This is PADT's other server room. It's also the louder server room of the two. And in here we have our business systems machines, as well as the rest of our cluster that gets us to 240 cores. We also have our phone system and our connection to our office in Colorado in this room. Sometimes when PADT works with customers, we get working together so closely that we decide that co-location is a good answer. OrthoSensor, who's our largest medical customer right now, is one of those examples. So they're co-located here with us, the folks that from their office that work here in Phoenix, and that way we can get a lot done faster. So it's been a nice relationship that's worked out well for both of us. This is our sterile lithography room where we have our SLA machine as well as our PolyJet machine. The SLA machine, if you remember, makes really nice quality parts, and it does that by drawing on a liquid vat with a laser. Everywhere that laser hits, the liquid turns to a solid. Then if you see that metal grate, it's an elevator that goes down just a little bit, and then it puts a new layer of material on top and hardens that layer with the laser. It does that over and over again until it builds a complete part. This is our PolyJet machine. If you remember, this was the one that makes plastic parts that can be soft or hard or anywhere in between. It's actually an inkjet printer that uses materials similar to what that runs in the SLA machine, but it uses an inkjet print head to put down little dots of either the soft material or the hard material and whatever mixture you want. And it just goes back and forth like a normal printer and builds the part up one layer at a time. So this is our oven room and our SCA room. Of course, the oven room is where we keep our ovens that we use for various manufacturing and tests, but it's also where we keep our SCA machines. A couple years ago, PADT introduced our first product that we designed and manufactured and distributed ourselves, called the Support Cleaning Apparatus. And it's used to clean the parts from the fused deposition modeling machines that you saw at the beginning of this tour. This is our molding area. Back here we can do injection molding. These are tools we've made for doing injection molding, and this big beige beast is our injection molding machine. And we can run several thousand parts on this machine here. If we need to do more, we have partners both domestic and overseas that we can send them to do in the millions of types of parts. We also do something called soft tooling, where instead of making a metal or epoxy mold, we make a rubber mold, and this is a good example of that. So we'll actually take a sterile lithography part as a master and pour rubber around it to make a really high quality rubber mold, and then we can inject the plastic that we want to make the part out in this mold. And we can get anywhere from 1 to 10 or 15, maybe even 50 parts out of a good mold. And it's a great way to get low volume production of complicated plastic parts. A trip to the shop is always full of surprises. We never know what we're working on. We work on parts for people all around the world. Sometimes they're consumer products, sometimes they're aerospace, sometimes it's someone's hobby. It's kind of neat to come back here and see what's going on. Besides rapid prototyping and molding, we also have a lathe and a mill, a CNC lathe and mill, that we can use to machine parts out of metal or plastic. So we can use newfangled fancy prototyping as well as more traditional manufacturing methods. This is our newest machine here in the shop. It's called a cross-sectional scanner. And instead of building parts one layer at a time, what we do here is we machine material off of parts one layer at a time. When we do that, after we do each layer, we take a picture of it with a high-resolution scanner, and that information is fed to a computer program, and we can build a very accurate 3D solid model of the part. This is a great way to inspect parts that you really can't inspect any other way, especially plastic ones that have internal features that are hard to measure using traditional inspection technology. This is the SLS, or Selective Laser Sintering Machine, and it's the last rapid prototyping technology we'll look at today. The way this one works is that there's a powder, and you can see the powder inside. Unfortunately, we don't have any parts to run today, so we can't show it to you running. But if it was running, you'd see the laser drawing on the very top layer of that powder and melting the powder so that it sticks together. Then the rolling pin goes across and puts a new layer of powder on top, and it does that over and over again. The great thing about this machine is it builds really strong parts really fast. So we like to use it to make large functional prototypes that we use in testing. This is the back of our building, and as you can see, we've got lots of room back here to expand. We can get access into our various labs and shops through these large doors. And you can see that besides the things we've already shown you, we have a full wood shop and a paint booth so that we can make all sorts of different parts for people. As we finish up our tour, we always like to stop here at our land of giant toys. Some of you may remember what a slide rule is. A friend of one of the guys that works here had this in his garage for some time, and his wife said to get rid of it. He knew that this was a place that would appreciate it, so we've proudly hung it up here in the middle of our offices. We also like to stop and take a look at our giant propeller. That's really cool because it's a nice piece of wood and it spins around and it's neat. But we also like to talk about it because it's a reminder of how important keeping up with new technology and our customers' needs are to staying in business. We actually ended up with this propeller because we were buying furniture from a company that went out of business that was involved in the CAD industry, who had invented a lot of the technology that was used at the time, but when new technology came along, they weren't able to adapt their software to meet the needs that the market was looking for. And so they went from being one of the leaders in the industry to actually, unfortunately, going out of business. And when we were purchasing their furniture from them, they asked us if we wanted this propeller. So we keep it here not only because it looks cool, but to remind us if we don't keep up with where the market is going and what technology is coming down the pipe, we'll have to give our propeller to somebody else, and we don't want to do that. Thank you for taking time to view this video today. If you'd like to learn anything more about PADT, you can always send us an email at info@padtinc.com. You can give us a call at 1-800-293-PADT. Visit our website at www.padtinc.com. Hopefully next time you're in Phoenix, or if you're here already, you can stop by and take a tour in person. We'd love to show you around.